Hi, here are some more problems on differentiation. Find the coordinates of the point on the curve y is equal to 8 over x squared at which its gradient is a quarter. We can write y as 8x to the minus 2, and we can find the gradient, which is dy dx is equal to minus 16x to the minus 3. So we're also told that the gradient is actually a quarter. So now we can equate, we know that the gradient is minus 16x to the minus 3, and we also have been told that the gradient is on that curve is a quarter. So we can write that minus 16 over x cubed is equal to a quarter. And from that we have x cubed is equal to minus 64 minus 64, so x is equal to minus 4. So we know our x coordinate is minus 4. But what is the y coordinate? Well, we can substitute here again to find y. Y is equal to 8 over minus 4 squared, which gives us a half. So we know our y coordinate is a half, and our x coordinate is negative 4. Now, one good thing about tackling differentiation problems like this is that you have an opportunity to summarize what you've done, which helps. It also gives you a good understanding of what you've achieved, even though it's really simple differentiation. So let's go ahead and summarize what we've done. So at the point on the curve y is equal to 8 over x squared, where the gradient is a quarter, the x coordinate is negative 4, and y is equal to a half. So therefore the gradient of the curve y is equal to 8 over x squared is a quarter at the point negative 4, a half. And that's our summary of the results that we've just calculated. Thanks for watching this video. Please remember to practice and practice some more. Bye for now. Hi, we need to find the gradient of a curve y is equal to x minus 5 brackets times x squared add 3 brackets at a point where x is equal to 0. So let's go ahead and simplify y. Y is equal to x cubed add 3x minus 5x squared minus 15. And we can rearrange that as x cubed minus 5x squared and 3x minus 15. So dy dx is equal to 3x squared minus 10x add 3. So now we have the gradient function, which is 3x squared minus 10x add 3. But we need to find what the gradient is when x is equal to 1. So at x equal to 1, so when x is equal to 1, dy dx is equal to 3 into 1 squared minus 10 times 1 and 3, which gives us negative 10. So we have a result that the gradient of this curve at the point x equal to 1 is negative 10. Let's go ahead and summarize this. So we can say, therefore, the gradient of the curve y is equal to x minus 5 bracket x squared add 3 is minus 10 at a point where x is equal to 1. Thanks for watching this video. My name is Alistair. Always remember to practice, practice, and practice some more. Bye for now. Hi, we need to differentiate f of x. So f of x is 6x squared add x minus 1 over 3x, and can be rewritten as 6x squared over 3x add x over 3x minus 1 over 3x. Therefore, we have f of x equivalent to 2x add a third x minus 1 over 3 x to the minus 1. So dx of f of x is equal to 2 add 0 minus a third brackets minus x to the minus 2, which gives us the final result of 2 add a third, or 1 over 3x squared. Let's rewrite that so it's visible. 2 add 1 over 3x squared. And that's it. Thanks for watching. Continue to practice, practice, and practice some more. Bye for now. Hi. We need to find the gradient of the given curve, and this is it. Y is equal to root x minus 1 over root x at the given, left the word at the given point on the curve, and that's when x is equal to 9. So we'll go ahead and assign this f of x is directly equivalent to over root x. Now we can simplify this to make it root x over root x minus 1 over root x, which is finally 1 minus x to the minus a half. Now we find the derivative of f of x would be equal to 0 minus a half x to the minus 3 over 2. And this gives us one over 2 root x cubed. So that's our derivative. Now we need to find the gradient at the given point, and that's where x is equal to 9. So therefore the gradient of the curve which is dy dx is equal to 1 over 2 root 9 cubed, and this is equal to 1 over 54. So the gradient of this curve, y equal to root x minus 1 over root x, is 1 over 54 at a point where x is equal to 9. Very important to summarize what you've actually found, your result. It makes for a good understanding of what you've done and not just a rote differentiation. Thanks for watching this video. My name is Alistair Harris, and I'll see you in the next video. Bye for now. Hi, here's another differentiation problem. We need to differentiate this function with respect to x. So we'll call this now f of x, and this is equivalent to 1 add 1 over x add 1 over x squared 1 over x cubed. And we can rewrite this with negative indices. And we can go ahead and now dx of f of x is equal to 0 add minus x to the minus 2 minus 2 x to the minus 3 and minus 3 x to the minus 4, and this becomes minus 1 over x squared minus 2 over x cubed minus 3 over x to the 4th power. And that's your derivative of the function y is equal to 1 add 1 over x add 1 over x squared, add 1 over x cubed. Thanks for watching. My name is Alistair Harris, and I'll see you in the next video. Bye for now. Hi, here's another differentiation problem I'd like to go through with you. Find the coordinates of the points on the curve at which the gradient has the given value. This is the curve y is equal to a third x cubed, add 3x squared, add 7x, add 1. And the given value is -1. So we could go ahead and differentiate our function dy dx, and that's equal to x squared, add 6x, add 7. So when dy, that's right, when dy dx is equal to -1, because they said at which the gradient has the given value, -1, the gradient is the same as saying dy over dx. Then we have that x squared, add 6x, add 7. We can also equate this to -1 because we just found dy dx by differentiating the curve. And this implies that we have x squared, add 6x, add 8 is equal to 0. So we have a quadratic in x, and we can go ahead and solve this by factorizing. We have x into x, add 4, 2 into x, add 4. I've skipped one step, but we should be able to factorize this. 6x splits into 4x and 2x, and then we factorize x squared, add 4x first, and we have this, and then we have 2x add 8, it's factorized to give this, and this implies that we have x add 4, which is common to x add 2, is equal to 0. So our solutions, x is equal to -4, and x is equal to -2. We have two values of x. So we've got to this point where we have two x values, -4 and -2. So at the point on the curve, y is equal to third x cubed, add 3x squared, add 7x, add 1, where the gradient is -1, the x coordinates are -4 and -2. So we just need to go ahead and find the y coordinates. So when x is equal to -2, we have y is equal to a third, -2 cubed, add 3 into -2 squared, add 7 into -2, add 1. And this is equal to a -11 over 3. And when x is equal to -4, we have y is equal to a third, -4 cubed, 3, -4 squared, 7 times -4, add 1. And this equates to -1/3. So what are our results? We have that the gradient of the curve. Right, just to summarize, we have the gradient of y equal to a third x cubed, add 3x squared, add 7x, add 1 is -1 at the points. So it has this gradient -1 at 2 points, because after finding the gradient of this curve, we had a quadratic equation in x, which means that we'll get 2 solutions. So we have 2 points at which the gradient is -1. At the points -2, 11/3, you could convert this to a mixed number, and -4, -1/3. Let's actually write this as a mixed number. So that's 3 into 11, 3 is 9, and 2/3. So the gradient of the curve is -1 at the points -2, -3 2/3, and -4 -1/3. My name is Alistair Harris. Thanks for watching this video, and I'll see you in the next. Keep practicing. Bye for now.